You all for joining our EV Charging 101 webinar this afternoon or evening. My name is Gary Chin, and I lead our Division of Professional and Continuing Studies here at Franklin Cummings Tech in Boston. Cameras and microphones have been disabled, but please feel free to enter any questions you might have in the chat, and we'll address them either during the session or at the end of the session. We're so grateful to be joined by Nicole Rudrin, who is the managing engineer of NPV Energy and the co-founder of the Better Together Brain Trust. Nicole leverages over 17 years of experience in energy management to provide consulting services for energy, climate, and transportation electrification projects. With a diverse work history, including roles as Director of Energy Services at Horizon Solutions and Senior Director of Operations at Amp Up, an EV charging network, Nicole has deep knowledge of the energy, climate, and e-mobility industries, and we are fortunate to have her share her insights and expertise through this free workshop. Before we get started, I would like to share my screen and share a few opportunities that we have related to electric vehicle charging and charging infrastructure through our continuing studies department. So if you go to the franklincummings.edu website, you'll see the EV Charging 101 webinar is right now. And we have two classes that are coming up. One is actually starting next week. And it's a charger installation and maintenance course for electricians. This comprehensive program spans 3 evenings, and it covers hardware basics and hands-on troubleshooting. It'll be led by industry expert Stephen Porter, who is a full-time instructor with the college, and he brings over 3 decades of experience as the former chief electrician at Liberty Mutual Insurance. By the end of this course, you'll learn how to repair, maintain, and install level 2 EV charging stations, and you'll also receive 3 ChargePoint certificates to add to your credentials. We have had some students take this class, and they're now licensed and certified to install ChargePoint in the state, which is awesome. Steve, I'm going to go on mute, and you can introduce yourself and say hello to our attendees.
Hello, good evening. My name is, like Gary said, my name is Stephen Porter. I am a master electrician in the state of Massachusetts. Hopefully everyone's here from Massachusetts. I am a full-time instructor at the course. I teach EV charging, and besides that, I teach students code, theory, electric motors. Also, my background is I've been chief electrician for Liberty Mutual 32 years, retired from there, and now I'm a full-time instructor. Gary and myself from Meredith set up this EV charging program for electricians and maintenance personnel. So it's all hands on. We do have EV stations set up in the lab that we wired up. We got to hands on. We got to program them, troubleshoot them, and at the end of the course, we do get certified in ChargePoint. ChargePoint is one of the leading manufacturers right now of EV charging stations out there. Like I said, I know during the State of the Union address, President Biden said that over 500,000 stations going to come up. It's an up and coming technology right now, and there's a lot of job opportunities for charging to install it. You got to be licensed electrician, but to maintain it, you just have to have some electrical experience. So there are lots of opportunities out there, and like I said, next Monday the course is going to start. And any other questions, just feel free to ask me.
Awesome. Thank you, Steve. Yeah, President Biden said 500,000 charging stations, and we need people to do that work, and you can develop those skills with us. Um, the next offering is actually going to be led by Nicole as well, and it's also an in-person offering. So if you're in the Boston area, you could check out our EV charging station site assessment class. This is for property managers, construction managers, developers, um, and in 3 hours, you'll learn to evaluate commercial parking locations for EV charging readiness and design installations that prioritize user comfort and compliance. Um, so this class involves a field trip, and you'll be able to apply your newfound knowledge in a real-world setting. So yeah, these are two offerings that we're going to have in person in Boston, one next week, and then one will be in the summer. Um, I don't want to take up too much more time with this. Without further ado, I'm going to stop sharing my screen and pass it off to Nicole.
Fantastic. Thank you, Gary. Thank you, Steve. I really, really appreciate it. If you give me a beat, I'm going to make sure that my presentation is up and that I'm sharing the correct screen. So I'm loading that currently. Also, thank you to those in the audience. We're really excited. We would not have this program if you were not here. So this is really exciting. I love talking about EVs, charging, the industry. Um, so I'm just really excited for this next about an hour that we have together. Okay, Gary, is this my audience screen or my notes screen? Can you let me know what loaded?
This is audience, so you
All
look
right,
good.
awesome. Our little dress rehearsal taught me what to do. Okay, so we're going to go on a little journey together this evening. I had pitched the EV 101 content to Gary and the team at Franklin Cummings, and I had conceptualized it, and I have all of the data that I've gathered over the last couple of years, and in particular, I try to keep it fresh. And to when I was finishing my slides today, I wanted to take you all on a journey. So we'll see where we end up, but we're all going together. Um, Gary gave a really great kind of overview of me. I am an engineer and I've worked in the pseudo utility industry or utility adjacent industry for the last 18 years. I am the co founder of the Better Together Brain Trust. Today, I'm representing my solo consulting and workforce teaching company, NPV Energy. This is my dog Gertrude. So, full disclosure, you may hear her or our new puppy barking in the background. Um, I took the time to make sure the content was good. I have not put the new puppy photo up yet, so I'm very sorry. Next time, I promise. This is a legal minute, which actually has way more to do. I'm just going to skip through it. Has way more to do with when I teach the site assessment course than kind of talking high level about EVs in the EV industry. Steve must have gotten a little, preview of what my slides look like. Why are we here? The US needs more folks trained in this industry to be able to meet the very, very aggressive goals that are not very long from now expected to be met. We currently have a goal of 35,000 electric vehicle technicians. So that's a mix of folks that can work on EV chargers and do preventative maintenance and that sort of thing, as well as licensed electricians that can actually install them and do, full scope maintenance. Today, there's only 10,000 technicians and folks capable of working on them. Only 10% are women and only 5% are minorities. So, for Franklin Cummings to be kind of ahead of the pack, I haven't seen too many EV charging specific trainings. And I try to keep my thumb on the pulse of what's going on in the industry. So, it's really exciting just to be part of an organization that is all in on developing the workforce. Um, why are we here too? Companies that you hear their names in the EV space, they are all investing in training the workforce and hiring the workforce and paying really great market wages for trained folks. Tesla, GM, Siemens, EVgo, ChargePoint, Electrify America. You may have also heard of an organization called Charger Help, and they are explicitly working on workforce development and training and making their way across the U.S. with a training curriculum that they've developed. So it's a really exciting time to be in this space. It's also kind of like the Wild West. This figure this came out this past week. And another reason we're here is because EV sales are outperforming the majority of projections. So you get all these very brainy people who crunch numbers and make projections based on what information they have. And if you see, I apologize if you're colorblind. This bar here is actual EV sales. And then to the left, these are all the folks that were lower, they projected lower EV adoption than what actual ended up being. And the folks to the right are people that were higher than actual EV sales in the United States. So I think, it's more than a fad. We're progressing along the adoption curve. The early adopters have adopted, and you'll also see a lot of headlines. And for instance, Hertz going all in on EVs and then kind of coming back on that because they didn't do all their market research necessarily on the costs to repair electric vehicles that are short-term rentals. It's great for the resale market of electric vehicles. And in Massachusetts, we actually do have a rebate for electric vehicle adoption when you purchase a used EV if you have a qualifying salary. So that's a lot of information. We've already started on our journey together. I like starting with a glossary and kind of, just explain terminology. As an engineer, I use a lot of what I call TLAs, or three-letter acronyms. Just what we need in all of our industries, more acronyms. BEV, battery electric vehicle, which would be like your Teslas, Hyundai and Kona, Hyundai Ioniq 5s. These are full battery electric vehicles where they only run on electricity. There's also plug-in hybrid electric vehicles, or PHEVs, where they have both an internal combustion engine and a battery, but it's much smaller battery. So you only get 30 to 40 miles of electric range before your gas motor comes in for you and back you up. ICE, internal combustion engine. That's your traditionally fossil fueled vehicles, gasoline, diesel, different petroleum based. You even have some propane, natural gas powered vehicles, mostly buses, and I think some trash trucks. MPGE, miles per gallon equivalent. This is what is used to compare energy consumption of electric vehicles to a more common, what more well-known value of miles per gallon that we're used to with our traditional ICE vehicles. EVSE, electric vehicle supply equipment, also known as a charging station, EV charger. And SOC, state of charge. That refers to how much percent you have left in your electric vehicle's battery. And then I skip ahead, range anxiety. This is one of the, I think, top 3 reasons people have not adopted electric vehicles yet. Another being affordability. Electric vehicles definitely have an affordability issue, which we're seeing some headway towards currently. Lots of great lease deals and that sort of thing out there now. But range anxiety it's a big reason why I did not adopt an electric vehicle back when I bought my last vehicle. And there just weren't enough charging stations as far as I was concerned. I didn't think that the vehicles that were on the market when I was looking about 3 or 4 years ago, they didn't have big enough batteries. They didn't have far enough distances that they would go. And I just felt like in the area where I live was a bit of a charging desert. I have since lost my range anxiety because of knowing that I would actually start every day with a full battery, because I am fortunate to have I own my home, so I can install my own EV charger. There's folks called garage orphans. I should probably put that in the terminology list. But, folks who live in more urban areas or in multifamily, multi-unit dwellings, and they don't have dedicated spaces to charge their vehicles. So range anxiety will continue to be an issue until we see more retailers installing charging stations, more municipalities, etc. Okay, so my range anxiety is dispelled. There's way more vehicles on the market that have longer ranges. I'm privileged and fortunate to be able to charge at my home when it's time. Uh, and then I think this past year in particular, it's probably been since last June, July, I want to say, but there's been a lot of headlines about NACS, NACS. You'll probably see that splashed everywhere. NACS is a very aptly named charging standard. Tesla created their own proprietary charger for Tesla vehicles because they were moving faster than the market. And they called their own standard the North American Charging Standard. One great thing is they made it open and they allowed anyone to use that charging standard. So it was proprietary but open at the same time. And since last July, first Ford said that they were going to be adopting that standard. And then all of the dominoes have started to fall over the last, how many months is that? 8 to 9 months. And all the other vehicle manufacturers are adopting that as a fast and I'm just going to say as a charging standard. I'm getting ahead of myself. I use different terminology. So the Society of Automotive Engineers, which I probably should put in this glossary as well, they have adopted the North American Charging Standard and they're allowing it as an actual charging standard. And it's now called the J3400 SAE, Society of Automotive Engineers Charging Standard. So it's pretty exciting. More headlines that we saw this last week is Ford our vehicles are actually now able to do the charging. Tesla and Ford duked it out and made sure that the network is now open to Ford electric vehicle owners. They do need to have an adapter to be able to charge in the Tesla vehicle because their electric vehicles were manufactured with the CCS or combined charging standard port. And we will start seeing probably the end of this year, but maybe not till the beginning of 2025, we'll start seeing vehicles rolling off of the manufacturing lines, non-Teslas, with the NACS port native to the vehicle. So they'll no longer need an adapter. There's only a small period of time where adapters will need to be used, which is also why there's probably some really great lease deals right now on electric vehicles because they want you to be encouraged to adopt an electric vehicle now, but know that they'll be ready to lease or sell you an electric vehicle with a native charge point on it when your lease is up. Okay, so this table has a lot of information on it, but it's some more terminology for us. There are currently 3 levels of charging most ubiquitous in the EV charging market. There is a level 1, level 2, and level 3. Level 1 is slow charging, trickle charging. It's, I was going to say good, better, best, level 1, level 2, level 3, but that's not necessarily true. So when you are parked for a very long amount of time, level 1 charging makes a great amount of sense. I believe all electric vehicles, if the manufacturers haven't just started, charging everyone for a ton of add-ons, but I believe they all come with a level 1 charge cord that you plug into your vehicle's charge port and you can plug it into a standard outlet in your home. It takes a very long time to charge on a level 1 charge port. You will see I have a charging time column and there are ranges. The reason that there are ranges to how long it takes to charge at different levels of charging is dependent on a bunch of factors. It's not just rolling up to your local fueling station like Cummings or ExxonMobil or what have you, and refueling your X amount of gallon tank and going off. Usually, when you fuel at the gas station, you have a pretty standard flow rate from the gas pump in your vehicle, and you have uh, a level of fullness and a capacity, available capacity, and then the pump will shut off when it gets too full. With EV charging, you have to consider the size of the battery, the existing state of charge of the battery on your vehicle, the size of the onboard charger, the temperature of your battery, and the power of the charger. So when someone asks how long does it take to get to a full battery? The answer is depends, and those are all the reasons why. Um, Okay, so level one, trickle charging. You need to have a really long parking time or what's called dwell time in the industry. So, this is like overnight parking at a multi-unit dwelling. This is parking at your garage at your home. Um, you won't necessarily see it at workplaces unless you work very long shifts. Um, More traditionally at you know, I guess grocery stores and different retailers at municipalities, they've been installing what is called as level 2 charging. Level 2 charging is also AC charging at like level 1. AC is alternating current. Alternating current is what is coming out of our power grid. And we're going to see higher kW or kilowatts of power coming out of those chargers. Again, it depends on the charger and the onboard charger of your vehicle. Oops, sorry, I just knocked my own coffee. Vehicles have onboard chargers that kind of regulate the flow of the power from the charger to the vehicle's battery, but it also converts the power from alternating current to direct current for battery storage because batteries use direct current power. Let's see, Steve, what am I leaving anything out? Am I doing good so far? I'm not an electrician, full disclosure.
No, you're doing great. Like also, just to tell the folks out there, if you do not have, just a brief, and in my course I teach that, if you do not have the power in your house, don't worry about it. They do have a energy management system that will actually, because as we all know, and I'll just make this short, as we all know, we're not going to use your stove, your AC, and your car charger all at once. They do have an energy management system that you hook onto the electric panel, and with the electric panel is it's like an A/B switch, and you can actually charge your car up. When the car's done charging, then it goes back to your AC or a stove. So don't feel free that you have to go out and spend $5,000 on a brand new service. I am available though, but don't go out and see you have to spend $5,000 on a brand new electric service when you can just do a energy management system. But as the coach said, I would use even in your house, if you have 208, I would use a level 2 charger. It's a little bit faster than just plugging into your regular 110 and just waiting all year long. As you said, fortunately, that's great with you because I have a fear of just like you said, I don't have an electric car. I'm an electrician. I wired up several of them. I do know, gotta admit though, my sister does have an electric car, and she has two cars. She has a Tesla and a Rivian. But I do not have an electric car, but I do want to get one. But the miles I do, I don't think I could. I don't think I could come up with longer miles for it. But yes, you are right about the level chargings.
All right, excellent. Thank you, Steve, so much. Yeah, absolutely. A lot of folks don't have the available space or capacity in their home panels, and they might even have, we have a pretty old housing stock in New England and in Massachusetts. There might even be knob and tube wiring, which is a super outdated type of electrical wiring in homes. And there are programs through Mass Save to support getting rid of knob and tube wiring. And also, to Steve's point, there are energy management systems where you can kind of share the EV load with something that you're not going to be using at the same time. And that way you will not have to pay to upgrade your service. I'm very fortunate. I have a home that has ample space and capacity for a future prospective EV charger when I finally adopt an electric vehicle. When people, I joke with folks in the industry a lot because I'm in the space and they can't believe I don't drive an EV. And I say it's because I know too much. We do have a question. Oh,
Perfect.
hey, Darwin. Oh, thank you. Appreciate it.
Fabulous.
I'm actually going to press the wrong button. I had anticipated a question like this and I keyed up a website. Okay, so the question in the chat, thank you so much, Craig. I really appreciate you stepping up and asking a question. Should we assume that a normal charge is about 25 kilowatt hours? Great question, but it's not the best assumption. The normal charge is going to depend upon the battery size of your vehicle. And can I get a thumbs up that I'm showing a website with blue bar charts on it? Thumbs up. Excellent. Thank you. I am going to put this website in the chat. It's an EV database. Unfortunately, it's not US only vehicles, but you can find US vehicles on here. These numbers with the blue bars is the kilowatt hour size of each battery, which in turn will dictate the range or how many miles you can travel in the vehicle. If I scroll to the top, you will see the average of all of these electric vehicles. It's not of only on the US market, so tons of caveats here, but you will see it's about 71.7 average kilowatt hours per battery across all of these vehicles. If I had prepared better, I could do some really high level math with you. But the kW of the charger, assuming that the charger provides its full power and isn't having a load share or some type of capacity issue or its own power management. Say you have a 70 kilowatt hour battery and you're at a 10 kW charger. You plug into that for about 7 hours and you will get from 0 to 100% state of charge. However, I'm going to touch upon something later that you don't want to go to 0% charge and you don't want to necessarily charge all the time to 100% charge because of battery health. So I am going to reshare my presentation and hopefully I will do it correctly. All right.
Looks good.
Thumbs up if it's back there. Wonderful. Thank you. Awesome. Thanks, Craig. Appreciate the question. Hope that was illustrative. I was thinking I want to show a picture of a charge curve because you're, let me just write myself a note so I don't forget, and I can do it at the end. Okay. So level 2, still alternating current charging. It's mostly going to be what you're installing in your home. It's, if you stumble upon a free charger anywhere, it's likely a level 2 charger. Um, I'm going to actually skip ahead a couple slides and show you the EV charging pyramid. And what this pyramid shows is where and what types of charging are going to be used predominantly in a bunch of projections. Gary, do you have a cell phone?
Yes.
Where do you charge your cell phone?
Usually when I go to sleep, I have an end table and I plug it right there.
All right, so there's your home charging right there. We're going to start needing behavior change with EV charging. We can't treat electric vehicles the way we treat ICE vehicles. First off, because there's not an EV charging station on every corner, but also because you can't refill your tank or your battery in 3 minutes or 5 minutes the same way you can at your local or corner gas station. We're going to be treating our vehicles more like kind of our cell phones and how we charge our cell phones. So most charging is going to be happening where we're dwelling the longest. So I also charge my cell phone on my bedside table when I sleep. Occasionally, I'll need to top up during the day, and it's at my home office. It's right. It's I don't know if my mirror is inverted, but it's on my left. um, my phone gets plugged in on my left while I'm at work, and it's not plugged in as long because that's a faster charger than the one in my bedroom. Um, Next, it's talking about intra-city and intercity. We're not going to worry about those, but I talk to a lot of folks in the industry, people wanting like quotes for chargers, and they always want a DC fast charger installed as fast as possible. But when they hear that it's, upwards of $50,000 to $100,000 to install, even with the really generous incentives and programs with the utilities, they kind of change their tune because then we have a discussion about when and where charging is going to happen and what type of charging is needed. So I mentioned DC fast charging. DC fast charging is also level 3 charging that I mentioned earlier. It is direct current charging. So it actually bypasses the onboard charger of battery electric vehicles and goes straight to the battery. You can actually get power up to 350 kW. We're talking about for traditional passenger vehicles. Fleet vehicles and, heavy duty vehicles are likely going to have higher charger capabilities, bigger batteries, etc. And that is, kind of your top up charging. You should not be charging your vehicle with DC fast charging all the time. The same way you shouldn't be charging your phone on a fast charger all the time because it starts to degrade the battery because lithium batteries, which the majority of electric vehicle batteries are made out of, have a certain amount of lifetime cycles that they can be discharged and recharged. But I folks are kind of up in arms about battery life and degradation, and they're in the industry, they're not seeing it as bad as people had anticipated, which is great news. What else did I want to touch on here? I think it's in a future slide. So I told Gary I was going to ask you all for forgiveness because I'm an engineer and not a graphic designer. I know this doesn't look super great. The colors are kind of wonky, but so there's a majority, there's two, well, I guess there's three. Before I go on to this, Natasha asked, is the level 3 charger fine to use when traveling? Yes, absolutely. They're fine to use all the time, but they're not, you don't want to rely on it for 100% of your charging long term. Yeah, when you're traveling, you're absolutely going to need to rely on level 3 chargers because you're not necessarily going to have long dwell times. Um, you're going to travel, recharge. And that's really what the level 3 chargers and DC fast chargers are meant for, is that type of driving. Um, which I mean, traditionally folks don't do that on a day-to-day basis where you're driving further than your vehicle's range. Okay, back to this poorly designed photo. um, J1772, I meant to mention that back in my terminology slide, but that is what is a level 1 and level 2 charge port, and this is actually a photo of what it looks like. So level 1 and level 2 chargers will plug into non-Tesla vehicles, non-Tesla manufactured vehicles. And this is what the charge port looks like. And then when those vehicles plug into level 3 chargers, you can see this top looks just like that because it goes into the same port. But the level 3 charger will also have this part down here. You may need to like flip a little cover open on your charge port on your car to make access to that, make it more accessible. Um, One thing I wanted to mention too, I think we talked about plug-in hybrid electric vehicles a few slides ago in the terminology slide, where they have both a small battery for electric range and then they have a gas tank for gas range. Those vehicles are not able to charge on level 3 DC fast chargers. They can only charge on level 2. That is by design because they only have, again, 30 to 40 miles of electric range. Um, so you don't need a very long dwell time at a level 2 or level 1 to fill that up. On the right here, we have our NACS/Tesla charge port, and that's what Teslas all use, and it's what basically every other vehicle manufacturer in the United States is starting to use, starting with Ford and Rivian, and we're going to see more and more in the headlines being able to access the Tesla network. And I'm going to speculate, but a lot of the reason why vehicle manufacturers are supporting the formerly Tesla charging standard is because the Tesla charging network is one of the most expansive networks. There's the most chargers, and the charging experience is the best. Now, I don't own an electric vehicle, but I've driven and test driven and rented a dozen plus electric vehicles. I don't love driving a Tesla. I will likely never own one. But when I had to charge it at a Tesla charging station, it absolutely, bar none, was the best charging experience at any charger that I had. I probably have 20 different charging apps on my phone. So that way I could access all the different chargers available on my travels. Um, One of the great things about Tesla is they have fully adopted a plug-in charge standard where you plug the charger into the vehicle, it makes its handshake, and it just knows to charge you through the vehicle. Whereas with other charging stations, it's kind of like Gary, do you ever use like a debit or credit card at the grocery store or the gas station?
all the time.
Yeah. Are they all the same every time you interact with those terminals? Is it the
No,
same sequence of
some
buttons?
some are tap, some are chip. Yep.
Yeah, okay. So non-Tesla charging stations are very similar, where they have different mechanisms to make that handshake and say, hey, I'm going to pay you, or hey, even if it's free, just so you know, I would like to charge on you. So you need to scan a QR code or tap a card or swipe it. Most of it is actually through the cell phone. But every single one has a different secret handshake, is what I say, both with the debit terminals and with the EV chargers. So there is a standard out there for everyone else to start adopting plug and charge. And the industry is slowly moving there. But again, Tesla just kind of ahead of the pack. All right, there's our EV charging pyramid again. Let's see if I skipped over anything here that I wanted to cover. PEV here stands for plug-in electric vehicle, but I thought that would be too confusing to use that acronym because we also have plug-in hybrid. So I prefer the BEV for battery electric vehicle. Oh, so I like this axis here, kind of axis, I guess maybe it's the leg of the triangle, but so it's saying that home charging is time insensitive. So it's not urgent to get your vehicle battery charged when you're at home necessarily. Workplace is semi-public charging, whereas you have more public AC level. Haven't seen a lot of level 1 outside of just plugging in at home. But yeah, the different DC fast charging options. And then as you go up the pyramid, it increased capital costs and non-owner involvement. Like I believe it means non-vehicle owner. I gotta admit, I'm blowing through these slides way faster than I anticipated, so I might actually run out of content, but I could still talk anecdotally to a heck of a lot of things. All right, Craig in the comments. Let's see. Okay, could you comment on the level of current typically used to charge a Tesla? I cannot, but I can report back because I usually deal in level 2 in DC fast chargers that are non-Tesla. So, and because I also don't own a Tesla, I'm not as familiar with their level of current. They are DC fast chargers, however, so they're going to be 200 to 920 volts DC. And then they have varying levels of kW power as well. How a charging unit knows that a lithium ion battery is fully charged. So when you plug an electric vehicle into the charging station, you're going to have a handshake between the vehicle and the charging station. And the vehicle reports back to the charging station what its state of charge is. So it does get controlled usually through like your onboard, your display will let you know what your state of charge is, and it estimates how much time, and it also gives you a reading on what the kW being fed into the vehicle is. Does it monitor the percent of battery capacity needed to fill it? Yes. The accuracy of the monitor remains to be seen. I'm not totally sure. It's been pretty accurate on the vehicles that I've test driven and charged and that sort of thing. All right, let's see. I need to report back on actuals Tesla current. All right, Gary, you asked, what is the difference in cost to install a level 2 charger versus a level 3 charger? Okay. So with the explosion of adoption in this space and the very high adoption growth rates, there is a lot of funding, and there's also very many EV charger manufacturers and brands on the market. So you can have a level 2 charger for your home that costs $500 just for the charger, plus the install. What would you say, Steve? Install of a $500 level 2 charger. You got both space and capacity in your panel.
Probably about $200 because I believe that it's a stock they'll kill you because you have to depend on your breaker where the panel is to the garage where you're going to do it.
Oh yeah, the distance. Yeah,
the
yeah.
distance.
So
why,
it can be like 800 to
Probably-
1,000 all in for
Yes.
a home charger. Okay.
Yeah.
Yeah, depending upon where your panel is compared to where you want the charger to go. It also depends on if you install the energy management system along with it.
Correct.
Yeah, so sorry, the answer is it depends, and there's a lot of variables, but I think 800 to 1,000 for a level
Yeah.
2 charger in a home is a pretty solid ballpark. Now, if you want to have a charger in a parking lot at a commercial retailer, the more commercial level 2 chargers that have, cellular connectivity, it has, a network or an interface where you can control how much to charge, the cost of charging, in different kind of like parking rules and that sort of thing. Those chargers can be from 2,500 to 10,000 just for the equipment. Sometimes that includes, warranties, preventative maintenance plans, reactive maintenance plans, software network, and that sort of thing, plus the labor to do all of that. And that labor and other materials aside from just a piece of equipment are dependent upon how far the power source is, as Steve and I just discussed. Do you need to trench through different materials of things? It's a lot easier, more affordable to trench through grass and dirt than it is through asphalt that needs to be repaved, or concrete or cement or that sort of thing. And then there's kind of, the ongoing operational costs of those level 2 chargers. Level 3 chargers, I've seen some that are on the lower power end, maybe 30 kW. And I'd say those are 25 or 30,000 on the lower end. Plus installation costs. You're likely always going to need a power upgrade for a level 3 charger. It's very rare that you'd find a facility or a building with not only the space for the new breakers, but the capacity to allow the chargers to operate, because they're considered a continuous load. So you actually need, you're subject to the 80% rule, which if you take Steve's class, I'm sure he tells you all about. All right, let's see. Brian. Can you speak to the safety of the batteries? I've heard some fire departments are concerned about putting out these batteries when they catch on fire, even so much that some communities are asking that EV charging parking spaces be located on the outskirts of parking lots. Okay. I do not have the data handy, but I can follow up with it. But internal combustion vehicles catch fire more often per capita than electric vehicles. However, when you have an internal combustion engine fire, it is much easier to put out than an EV vehicle fire, because with the electric vehicle fire, when and if it happens, it tends to smolder. Whereas you're able to stop the combustion of if an ICE vehicle caught fire. They are safe, assuming that if they were recalled, that you went through the appropriate manufacturer's safety protocol. But I have also heard the same thing. There are some fire departments and authorities having jurisdiction being very particular about where EV charging can happen. Gary, thank you for answering Natasha's question about the courses offered. And yeah, so to maintain EV chargers, you do not need to be a licensed electrician, but you do need to be a licensed electrician to pull wires and that sort of thing, and then do the full installation of the EV charger and any related infrastructure. Awesome. So we got 9 more minutes. We covered some questions. I got a little bit of more content. We're doing good. We're right on time. Okay. EV charging tips, something I've already covered. Don't rely solely on fast charging. Fast charging is not bad, but it can degrade your battery life if you rely only on fast charging. Also, for battery life, and this is one, do as I say, not as I do. Aim for 80% charge, not 100% charge. This is a suggestion to maintain battery life. If you charge beyond 80%, don't try not to charge beyond 80% on a fast charger. It's okay to do it, it's safe to do it, but if you do it, just don't make a habit of doing it all the time. Again, it's a behavior change thing. My husband gets after me all the time. My gas light goes on and I'm running on fumes before I refuel. But with electric vehicles, I've rented them some for long term for a couple weeks. You kind of need to make a plan to know where you're going, where the charging's gonna be, and make a plan when you're at 20 to 30% state of charge. Where am I getting topped up, or where am I going to get to 40 to 50, and go from there. You got to kind of manage that. And then the last piece I touched on a little bit, but you got to know what chargers your vehicle is compatible with. So again, the plug-in hybrid electric vehicles, you cannot charge at fast chargers or DC fast chargers. But also, some vehicles are not capable of charging up to 350 kW. And it's not the best etiquette to roll up to a 350 kW charger when you're not able to accept that full power. And oftentimes you're paying more money for non-Tesla. You're paying more money to be at that charger per kW, and you could get limited to 100 kW or 150 because of your vehicle. So make sure. I don't think dealerships are really great at educating new EV drivers just yet, but there's tons of resources out there, and I'm happy to be a reference to help you, support you. Excuse me, I have hiccups. Oh, another myth that or I guess a myth that I wanted to dispel too. I've heard this a lot, that electric vehicles have a larger carbon footprint than ICE vehicles. And just this past week, Canary Media put out this really neat bar chart from Bloomberg. And if you see here to the far right, this is a US battery electric vehicle. And this is a internal combustion engine in the US. You'll see the red is vehicle manufacturing, and it's about even. When you drive an electric vehicle off the lot, or you pick it up from wherever it's getting delivered to you, you have a higher carbon footprint because of the battery pack manufacturing. But over the lifetime of your electric vehicle and the miles driven, even if you're charging it with electricity that isn't 100% renewable electricity, you're going to have a smaller carbon footprint than an ICE vehicle. So I will also send in the chat. Oh wait, I can do it right now because I have it in my notes. James in the comments, level 3 charging is more expensive than level 2 at home. Yeah, exactly. Because most of the folks installing level 3 charging, they want to recoup that capital cost. They came out of pocket tens of thousands or maybe even hundreds of thousands of dollars for that EV charger. So they're going to charge you more than what their electricity cost is. Whereas at home, you're just paying the electric company for what that that power is. And hopefully your apartment property manager isn't trying to make a killing off of EV charging costs. Okay, so in the chat, I just sent the link to the Canary Media article, which this photo is from. And I also put in an EV tool from the Union of Concerned Scientists, and you can put in your zip code, and it'll tell you the carbon footprint of charging a vehicle in your zip code based upon the fuel mix of your utility. We made it. We reached our destination, everybody. I'm Nicole Vudrin. I'm a certified energy manager, owner and principal at NPV Energy. That's my phone number. I have 2 email addresses, one with Franklin Cummings. That's my LinkedIn, which I will also send in the chat. I would love to, oh, I can't. Sorry, it's the presenter mode. But if you search for Nicole Vudrin, I don't think there's many of them. And if you're connected to Gary, so am I. I really have appreciated our time together here. Thank you for listening to me chat my face off about electric vehicles. I did want to pitch, if I didn't cover something that you had hoped I was going to, I have dear friends at the Green Energy Consumers Alliance, and they're fantastic EV evangelists. So there's tons of resources at their website, about the rebates, the tax credits. They have an EV purchasing program, and they also have an EV 101 on their YouTube, if I didn't touch upon something you were hoping we were going to talk about today. Cool. Now I'm going to go cook tacos for dinner.
All right. Thank you, everyone, so much for joining us. My email as well is just gchin@franklincummings.edu. So if you have any questions that we can follow up on, you can always email me and we'll get you an answer. I hope everyone has a great evening and thanks for joining.
Bye, everybody. Thank you so much. Have a great night.
Bye-bye. You too.
I think I'll stay and answer some questions if they pop up.
Yeah, I've got a few minutes, so looks like there's someone who asked about what the demand is for EV charging system designers.
I am typing up a response. I guess I could just talk it. So there are, let me pull up a charging station installers, National Grid. Grid posts a list of companies that work directly in their EV programs. And most of the companies are already kind of in the mass save commercial programs. And I know that many of them are often looking for folks that have, kind of the EV lingo down. And I certainly have found no shortage of opportunities as a consultant in this space, teaching people how to do the site assessments and being hired as a subcontractor to do the site assessments for different organizations. So there's definitely demand. Can't really speak to, average salary or, quantity of jobs anticipated, but we need to install hundreds of thousands of charging stations over the next 6 years. Someone's going to find value in folks that know how to do this and can talk to electricians to make sure they're checking their work, because I am not an electrician, I'm an engineer, but I like having that kind of, licensed verification that what I've talked about is sound. All right, cool.
Awesome.
Thanks, Gary. I appreciate you. Thank you,
Yes.
Steve. Appreciate you chiming in
welcome.
too.
Oh, Nicole, are you still with us?
I sure am.
Yep, looks like we've got another question. welcome, Natasha.
Natasha, shoot me an email. I just put my email in the chat. I'm more than happy to talk to you in depth about my thoughts on this. We need maintenance. There's reliability issues. So yeah, let's see how I can encourage you and help you get into the industry and start providing maintenance.
Fantastic. All right.
Thanks again. Bye, y'all.
Have a good night.
Bye-bye.